Okay, another 1 minute, eh? Just wait for your friends. This is going to be like attendance, so okay. Okay, so I think we can start now. Okay, so let's discuss. So you can see the slide, right? You can see the slide, eh?
Yeah, I can.
Okay, so audio clear, eh? Okay. Okay. So yesterday we learned about how to form the equation, right? If the pendulum is at the side and pendulum at straight, you have the three equations. Okay. X equals to sine omega t is a formula for displacement or which one? One or two? X equals to x dot sine omega t for the two. Yeah, class.
For two.
For the case of two, for the two, for the two, the sign, the displacement is sign. So velocity is cos and acceleration is negative sign. Okay. Yeah, I don't want to go about that later. Okay, so now just recall back. What are the three equations you must tell us to find displacement, velocity, and acceleration? What are the three information they must tell us? They must tell us the
period,
amplitude, the period, then
the start of oscillation.
the beginning of the oscillation, where it started, time zero, where is it started. Okay, so if they give these three informations, you can able to find these three. Okay, so the x value you can get negative, b value also you can get negative, a value also you can get negative. There is a chance to get negative. Okay, now see this slide. Okay, you see this slide. This slide tells us. Sorry, clear it. Okay, this slide tells us how do you find displacement. Sorry, how do you find velocity and acceleration at given displacement? A given what? A given displacement. You see the slide, the displacement of velocity of a body undergoing SHM been found in terms of time. Okay, time we already know. Okay, however, sometimes velocity is required in terms of displacement. Okay, they want in terms of displacement. For example, a pendulum, let's say here, and later it was here. Let's say it was displaced for 5 cm. Okay, your 5 cm is x naught. Okay, let's say period all given lah, period, and where it starts all given. Okay, let's say start from the center. I'm asking when the pendulum is displaced for 2 centimeter. It displaced for 2 centimeter. Okay, 2 centimeter. What is its velocity? Okay, how much is the velocity? So can you use the Vx formula? Can you use the Vx formula, like your Vx formula, this formula? Can you use this formula to find V when x is 2 centimeter? When x is 2 centimeter. Can you find it? Okay, you can't find. Why you can't find by using this formula? Because this formula is in terms of time. You give any time, you can find the velocity. But now we want the velocity at given displacement. So what do you have to do? We have to find a formula for V in terms of what as a variable? As your displacement. The displacement as a variable. Okay, so displacement as a variable. Like you see this formula is in terms of the V in terms of what? You know, you learn function, right? This is V in terms of what? In terms of T, right? In terms of T. If you learn function, it's in terms of T. So now we need to throw out the T. We don't want the T. We need to replace with what? We need to replace with displacement. We need to replace with displacement. Okay. So how we do that? Okay. Look at the diagram here. Yeah. So we use this displacement formula. We considering the pendulum is T0 at the center. Okay. So displacement is x naught sine omega t. If you make sine omega t as a subject, is x naught, x over x naught. Okay. We know V formula is omega x naught cos omega t. We already derived this. Okay, last time. From the first formula, we derived this by differentiating. You get this. Now we want the velocity formula in terms of displacement. The cos omega t we substitute. Okay, cos omega t we substitute. Cos omega t is same as this. You agree? Cos omega t is this. Okay. So cos omega t is this. Sin omega t is this. This is sin omega t. This is cos omega t. So you know trigo last time we learned identity. You still remember this identity? Sin squared plus cos squared theta equals to 1. Okay. So what do we do? The sin omega t x over x naught we substitute inside here. That means it's going to be x over x naught. Okay. Squared. Okay. Squared. Plus with cos omega t. Cos omega t is what? E over omega x naught squared equals to 1. Okay. From here, you just rearrange it, you'll get this formula. This is the formula you get. Okay. Rearrangement line. Okay. In your syllabus, the derivation, not in your syllabus, but you should know how to use this formula. Okay. So this is a new formula to find what? To find velocity at given any displacement. This is something new. It's any displacement. Okay. So the pendulum at 2 centimeter or 3 centimeter, you can find this Vx. Okay. So let's analyze this formula further. What is x naught? The amplitude. What is x? What is x? X is the displacement you want the velocity.
Displacement.
Displacement you want the velocity. For example, the amplitude is 5 cm, but you want the velocity at 2 cm. So your x will be 2 cm. Okay, x naught will be 5 cm. Omega, you know how you can get it. Okay. Okay. Now, can you tell me this formula? If you plot V versus X, how's this graph looks like? If you plot V versus X, how's this graph looks like? The maths knowledge. Is it going to be a curve, straight line? Okay, how are we going to be a? Okay, so anyone? This is the most weird graph ever in physics. You never come across this graph before. Only happens here. Okay, those who are good in maths, I think you can figure out this. Okay, let me help you. So V equals to omega just I put a number, it's a constant. Okay, I put a number, constant, I put a number. X naught also constant, maybe I put a 10, 10 squared. Okay, minus x is the variable, I just put x squared. Okay, so V, this is the formula. Okay, now square both sides, what happened? V squared, this become what? 100, and inside become what? Another, become what? Another 100. Okay, minus x squared. X squared. Okay, now you expand it, it become V squared, become what? 10,000. Okay, slow and steady. 10,000 minus 100x squared. Okay, so this is the graph. This is the equation, sorry. So I think in maths, instead of V, you are familiar with Y. So let me change to Y. Okay, just Y squared equals to 10,000, what? 10,000 minus 100x squared. How's this graph looks like? Anyone? Y squared, X also squared. Anyone? How's the pattern of the graph going to look like? Next, you learn about the graph section. Y squared, X squared. Y equals to X squared. How's the graph looks like? Y equals X squared. It's a quadratic, right? A smiling face or sad face, right? If Y squared equals to X, how's the graph looks like? It's also quadratic, but it will be this way, right? Okay. If Y squared plus, let's say, X also squared equals to a number, maybe 10. How's this graph looks like? Anyone? Give a chance to you.
Circle.
That's good. It's going to be a circle. It's going to be a circle. So this is a graph. So Y squared, X squared means it's a circle graph. So for this formula, sorry. Okay. So for this graph, it's going to be a circle. It's a circle. First time, it's a circle with what versus what? V versus X. Okay. Where this value going to be what? Your X naught. Okay. This value going to be what? Going to be negative X naught. The maximum value here going to be what? What is the V max? What is the V max? What is the maximum value can be here? Omega X naught. Because when X becomes 0, you get a V max. And when the particle, when the pendulum move at the equilibrium, your V is max, right? So V max is omega what? Omega X naught. Okay, so this is the graph. Okay, this is the graph for V versus X. Quite weird graphs. Okay, so remember, let's say I'm asking a question. As I told you, if you have a pendulum 2 centimeter away and its amplitude is 5 cm, okay, at 2 centimeter, I'm asking you to find the velocity. So you're going to use this formula, okay? You're going to substitute x as 2, x naught as 5, omega accordingly, assume frequency is provided, okay? How many answers you will get?
2.
You always get 2 answers. You see in this graph, any displacement, let's say 2 centimeter here, 2 centimeter, you'll get two values, one on top, positive, another value is going down here, negative. You get 2 answers. Okay, why you get 2 answers? Because at 2 centimeter, it might moving on the way to the left, or it might moving on the way to the right. We're not sure at 2 centimeter, is it moving to the left or right? Because we just determining the displacement only. We just ask at displacement of 2 centimeter, what is the velocity? It might move on the way to the left or right. Okay, like the oscillation is going like this one, going up and down. So it gives 2 answers. It always gives 2 answers. V equals to X. Okay, so this is velocity versus displacement. You're going to make a circle. You always give for 2 answers because square root plus minus answers. Yeah. So V equals to omega square root of X naught squared minus X squared. Okay. So when do you use this formula? When they're asking velocity at any given displacement, you use this formula. Okay. Okay. This formula has been derived by assuming the pendulum is at the center, time zero at the center, right? Because you see this formula is based on at the center. But how about if I use at the side, the x formula will be what? X naught cos omega t, So if I cos omega t, is it this equation going to be changed? They say no, they derived it, they found that it's the same formula. So this is a good news. Good news, but for any version, Vx formula is the same. Vx formula is the same. Vt formula is unique for different points, but Vx formula is always the same. Okay. Okay. So now let me go to the. Okay, this is the derivation. So remember the last formula is enough. Okay. Okay. So this case, let me go through this. Look at the. Yeah. Sorry. Okay, look at the graph here. So read the question. Figure A below shows our displacement x and A of a body varies. This is the displacement. Assume it's a cos graph. And A is, should be opposite of the x graph. So they're asking, vary with time t, SHM. What is the value of t? What is the period value? How much is t? Okay, how much is t? So what you can do, this is the working. So for figure A, the maximum displacement is 2 meter. Okay. For the figure B, A max we know is 18. So we know, so A max is negative omega squared x naught. That's your A max. Okay, that's your A max. So A is 18, x naught is 2, negative 2. You will get, when A is positive 18, your x will be negative 2, so going to be negative 2 because if you put x naught as 2, A you must put negative 18. Okay, opposite direction. So here A was 18, so x naught is negative 2, so you get omega 3. You get omega. Because you want to find the period, t is 2 pi over omega, so you can find the period. Okay, so you can find the period. Okay, remember omega, t, and what else? Frequency is like when you know one, you can get the other two. You can get the other two. Okay. Okay, this I skip. Yeah. Okay, class. So can you give a try this question? Read the question. Give 1 minute.
Okay.
Okay, so you understand the question. Okay, question, a particle move in a SHM straight line with the amplitude of x 0.05. So this is your what? This is your x naught. And the period of 12 seconds, so period given. So once you know period, you should know like you can work out your frequency, you can work out your omega already. Okay. So find the maximum speed. Okay. Remember, maximum speed, what is the maximum displacement? Is x naught. Okay. What is the maximum speed formula? Anyone? Omega x naught.
Omega x naught.
What is the maximum acceleration? This is maximum. What is maximum acceleration? is negative. Maximum acceleration is negative omega squared x naught. This is your maximum acceleration formula. You go back to your time formula, your A in terms of time. Okay, you have trigo. Whatever beside trigo, this is your maximum value. You know. Okay, the one beside trigo is actually negative omega squared x naught. That's your A max. So that's your A max. Okay. Okay. Now, first question: what is the maximum speed? So what formula must come to your mind? B equals to what? Omega
Omega
x naught. Omega
x
x.
naught.
Okay, so omega is, how do you get your omega? So you're going to know period
2 pi over 12.
2 pi over 12 and x naught is 0.05. So you get answer for the
Hmm.
maximum speed. Okay. How do you find maximum acceleration? Use this formula.
Negative omega square x naught.
Negative omega squared x naught. Okay, so you get the A max. Okay, now, assuming we got these two, now how do you write this formula? Write down the value of constant P and Q in equation P sine Q for the displacement. So x, we know x equals to x naught sine omega t. So comparing with this, P is actually what? P is your x naught. So P is how much? 0.05. That's your P lah. Your P. That's your P. Okay. What is your Q? QT, the QT. This QT, QT.
Omega.
So Q is omega. Good. Q is omega. So how do you get your omega? So as usual lah. 2 pi over t. You can get your omega. So this is the equation. Okay. So the next slide tells you that. Okay, so this is what the working. So V is omega x naught. Okay. Remember, V naught is omega x naught. Okay. A naught is negative omega x naught. Okay. Then this is the substitution. Okay. Okay, this all I'll keep. Okay, another one question. Come on, give a try. 1 minute. Okay, so this is the SHM equation. What is amplitude? What is the amplitude? Anyone? So this formula, yeah,
0.16.
yeah, 0.16. Your period, how do you work out your period? Anyone?
2 pi over
2 pi,
period equals omega.
2 pi, omega equals 2 pi over t. So t is 2 pi over omega. So omega how much?
3 pi.
Yes, got 3 pi. Okay, so you get your period in seconds. Good.
2
Yeah,
over 3.
203. Yeah, 203. Okay, then displacement at 1.5 seconds. What formula you must use? For displacement at 1.5 seconds. So you use this formula, right? Straight away this formula. So come give me the answer. I'm just checking whether you use your calculator correctly. That's the radian and the degree mode. Make sure the 3 pi t is in radian. Get me your answer first. Anyone? 0.16 times 3 pi t put 1.5 seconds.
0.16 here.
0.16 something. 0.16 meter. If 0.16 is meter, then the answer is in meter. Okay, so displacement, the formula you should know, you must use this. Make sure 3 pi times t is your in radian. It's a radian mode. Okay, next velocity. How do you find velocity in given time? What formula do you use? So this formula sign, you derive, you differentiate, right? So what formula? Sign you differentiate, you get cos, right? So use what? Omega x naught sine omega t, sorry, cos omega t, not sine.
Cos omega t.
Yeah, cos omega t, yeah, cos omega t. So you put all the values, you get answer for this one, velocity. Okay, for acceleration, what formula do you use? And we differentiate the velocity, right? So acceleration, you get what? What formula? Negative omega squared
Negative omega square
x naught
x naught
sine or cos?
cos cos
Cos or sine?
is sine.
Sine, right?
Sine.
Omega t. So you get the answer for the acceleration. So these three formula we learned yesterday. Okay, now see what formula to use. Determine the velocity and the distance is 0.1. So Vt or Vx to be used?
Vx.
Vx. V as the displacement as the function. So there is only one formula. What is that? That's not just now introduced. Omega square root of x naught square minus x squared. Sorry, I made a mistake. Omega, sorry. Yeah. Okay. Omega square root of x naught squared minus x squared. Sorry, x squared. This formula. So x naught you put how much? X naught you put 0.16. X you put how much?
0.1.
0.1. And you get the answer in terms of meter per second. This is how do you evaluate it. Okay. Okay. So this is the last part is something new. Displacement. Okay. Okay. So this is the working. Just now you got. So I think I already explained to you what towards the end. This is the formula to be used. The V equals to omega x naught squared minus x squared. So you get plus minus 1.18. 2 ounces. 2 ounces. So you get 2 ounces. Okay. Okay. So remember for V is equals to omega square root dot x naught squared minus x squared. Okay. Sometimes they ask find the acceleration at given displacement. Find the acceleration at given displacement. Okay. That one we just now you see this formula. This formula. This is your acceleration formula. Acceleration formula. This acceleration formula in terms of what? In terms of time, right? In terms of time. So what you throw out to f in the displacement function? You throw out the sine omega t. We don't want t. Okay. 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 So sine omega t. Got another 10 minutes. Okay. So they never throw sine omega t. They throw the x naught sine omega t together. X naught sine omega t is what? X naught sine omega t is what? X naught sine omega t is exactly your x, You see?
Amex.
You see? The x naught sine omega t is exactly x. That means the A formula tend to become what? Negative omega squared. The x naught sine omega t, just put x. This is the acceleration at any given displacement. So this is the last formula for you. You should know to find v at any given displacement and acceleration at any given displacement. These are the two formulas. Okay. Okay. The last formula, a negative omega squared x. How's the graph going to look like? Anyone? When you plot a versus x, how's the graph going to look like? Straight line, curve, circle.
Curve.
See,
Curve.
a versus x. A versus x. You put maybe a. I put it as a y. Okay. Okay.
Physical.
Omega squared. I put a number, maybe negative 10, and x. I put it as x. How's this graph looks like?
Straight line.
It's a straight line with positive gradient or negative gradient?
Negative.
Negative.
Negative gradient. So it's going to be a straight line like this. The pass through origin. Sorry, pass through origin. Okay, this is defining SHM. What is SHM? Acceleration is directly proportional to displacement, but in opposite.
In opposite direction.
Okay, so among all the graph I show you, this is the most important graph which defining SHM. A inversely proportional to X. This is the formula. Okay, so it's a straight line. Okay. Okay, so yeah, so remember add into your group, these are the two additional formulas lah. When they ask for velocity or acceleration in a given displacement, these two formulas you have to use. Okay. Okay. So let's see. Move on. Okay. Class. So this is something important today. Okay. Do you have come across with this formula before? T equals to 2 pi root of m over k. Do you come across with this formula before? Never come across, eh? This is the period formula for spring oscillation, okay. I think before we go to this, I go to the next slide. You see the next slide might be familiar. Okay, next slide, pendulum movement, very familiar. I think in your first semester practical, you did this experiment. Do you come across, I think you've seen this equation in your practical book, right? T equals 2 pi root of L over G. Okay, this is the period formula for a pendulum. Okay, for pendulum. Okay, now how they got this formula? How they got this formula? What is the origin of this formula? It's from SHM. Okay, from the SHM equation, they got a formula. So you need to understand how they got this formula. So we go actually like the origin of the story. Okay, so I'm going to explain to you about this, how they got this formula. Okay, okay, first, this is the important derivation. You see in this diagram, so pendulum's here, mg sine theta is the one restoring the force, mg acting straight down, tension is up, mg cos theta is here. Okay, the force which is trying to pull the object back is mg sine theta, negative mg sine theta. Okay, this is something new. This is called restoring force. Restoring force means never allow the object to move away from origin. Okay, restoring force in physics, they always put negative. Okay, so restoring force is always negative, trying to pull it back towards the equilibrium. Okay, so that's why we put negative. Okay, so in this case, the restoring force, we know the net force is ma. The restoring force is the net force lah. So therefore, ma equals to negative mg sine theta. Okay, so a is negative g sine theta. A is negative g sine theta. Okay, okay, now for a small angle of theta, you see this diagram. See this diagram. Okay, for a small angle, for the theta which is quite small, okay, very small, what happened? This x, and this s, the x is going to be about same as s. Okay, about same as s. Okay, because it's going to be parallel. It's going to be parallel. And when the theta is too small, when the theta is too small, do you know this in maths? The sine theta, we can take it as theta. Correct? Sine 0.1 degrees. You put it in radian, 0.1 degrees in radian. Your answer you'll get is also 0.1 degrees in radian. So sine theta is actually theta, only theta in radian. But theta is equals to what? You look at this triangle. Theta is equals to what? Look at this triangle. X over L. Sine theta is opposite over the hypotenuse, right? So theta equals to X over L. We only take this and the theta is too small. Okay. Okay. So for your case of exam, so yeah, it's X over L. So from here, on the top, this formula, the sine theta we replace with X over L. So you get this formula. So A is negative GL over X. Okay. In your exam, they will ask from here. They ask from this part onwards. At the bottom, you should know. The A is negative GLX. But because this is an SHM, must follow the SHM acceleration formula. A is negative omega squared X. Okay, so this you need to compare. So from here, you need to plug out the omega. You see here? By comparing the two formula, the omega squared is GOL. Okay, you always have to do that. Okay, so therefore you can find the period formula. So once you know omega, you can find the period already. That's why they got this formula. Okay, so in exam they'll give a acceleration formula unique to that system. Okay, let's say I give you unique. Sorry, okay, yeah, they give a acceleration formula unique for that system. You need to compare with SHM formula, A equals negative omega squared X. And you need to compare, plug out what is omega squared represents. You will have an X here, you will have an X here displacement. You have an A, whatever remaining is going to be omega squared. So in this case, omega squared is GOL. Once you know omega, you can find a period. Okay, so this is how the formula was formed. Okay, okay, class. So let's go for the system. Look at the spring. Okay, spring. How they got 2 pi root of m over k? Okay, I think okay, you see here, this spring is in origin, this diagram, okay? So when you extend it further down, you have a tension up, you have mg acting down, weight acting down, okay? So T naught is equals to mg, okay, T naught, okay? The T naught value is equals to mg equals to ke, k times e, the extension of the spring up. So mg equals to the extension force up. Okay, mg equals to k. K is what? K is E is the extension. Okay, when you at the diagram one, when you leave the spring haven't oscillate yet. It's in equilibrium, right? Okay, to oscillate, what do you have to do? You have to further extend it. You see, you further extend it down to another extra x. So this on top of E, on top of E, you extend further x. Now you will have a new tension T1, which is greater than the mg. So now you have a net force, which direction? Upwards. So how much the new net force? So when you see when the stretched further